Nitay Gold, and Will O'Brien. Nitay is the COO at CodeScan, and Will is the Director of Customer Success at CodeScan. And they will be presenting Gaining Speed and Confidence as a Salesforce Developer. Nitay and Will, thank you so much for being here. Feel free to go ahead and take the floor.
That's good. Thank you, Erica. Thank you, the Flossom team, and all the participants here. It's great to be here, and thanks for having us. As you said, we are going to have a quick session about showing everyone how utilizing technology and static code analysis specifically can gain you speed and confidence as a Salesforce developer. So here with me, as you said, Erica, at the beginning, is Will O'Brien. He has been a long time in the industry. Will, say hi.
Hi, everyone. Thanks for having us, Erica.
Yeah, we also have a special guest, Hari Krishnan, and he is the lead Salesforce platform architect at Syngenta. Hey, Hari.
Hey, Nitay. And hello all.
Great. So I want to open up by saying everyone knows the typical process of a DevOps. So everything starts from a design and then through development and then QA and then production. But something is happening at the development and the testing QA phase. So there is a loop between development to QA. So when you, as a Salesforce developer, develop something and you feel this is good and ready to be pushed into the UAT, testing, and QA, you push that through and something is happening there and it goes back to development. So there is an ongoing loop between development and QA that we all face with, and that caused mainly because a lack of processes, standards, and also technology. The other thing we know is that the later we find the bugs and issues, the more expensive they are to fix. So based on a survey that we have conducted and what we hear from our customers is that if we find a bug or an issue that was not captured in the testing, for example, and went into staging or even production, that costs 150 times more than it was captured in the design or development phase. So this is where static code analysis and other technologies can resolve those issues and reduce the technical debt that we push into production, reduce the cost and the time we spend on finding those issues, and technically just focus on business processes and not just reviewing code. So the main reason that this is happening that we have seen is a lot of lack of defined development standards. A lot of new engineers that are super talented are coming into the company and they give them free hand to do their magic. And when they do that and they don't apply the same standards for all of the development team, you see those discrepancies that technical debt is being pushed into production. The other thing, and Hari can speak about that a lot with the Syngenta case, is we see a lot of legacy implementation that exists in the system that has never been taken care of. So the technology is improving, but the code just stayed in the system and no one is cleaning that up. So this is exactly where static code analysis and other technologies can help you. And that brings into a situation that the development team doesn't see or don't get the visibility that they need when they're reviewing code through the code review process. So all of that is a situation of having that loop between development and the QA, and how the technology and using static code analysis tools specifically for Salesforce can resolve those issues and reduce the technical debt and improve the productivity of the developers. So Hari will share a few insights, very interesting insights about Syngenta and how Syngenta, with a super complex system, can manage or still managing to overcome those issues through technology. Hari.
Thanks, Nitay. So let me introduce myself. My name is Hari Krishnan. I'm the lead Salesforce platform architect, leading a team of architects from Americas to Australia's. So to talk about my company, like we are the largest agrochem company. Basically, we are into crop protection, seeds, lawn and garden, and veg business with a market cap of $40 billion. And we are the second largest agrochem company in the world. So we have like close to 45,000 employees, and Salesforce is our primary CRM platform, where we have more than 7,000 plus users. Can we go to the next slide? I'll talk more about the next slide. Okay, so we got a huge number of arcs, at least 24 arcs. And we, out of this 24 production arcs, we do have one main arc where we have the 7,000 plus internal users and thousands of external users. We support functionalities which is being currently used by 55 plus countries, and we are still planning to onboard at least probably like around a dozen countries into this main arc. The main reason is like, we want to consolidate and make effective use of our implementations, right? So this org is actually going to be even more complex in the near future. Talking about the current complexity, today we stand at like 12 plus million characters of code, and we have like more than 2,000 plus Apex classes, 500 plus Lightning components. This includes both Aura components and the Lightning Web components. And we have pretty much, more than 37 objects that has million plus records. And out of them, like at least like 6 objects has double digit, and 1 object has a triple digit million records. Like I think like the last one I checked a couple of months ago, it was at like 130 million records. As far as the data size, like we recently hit 500 plus gigabytes of data, and we are still growing on. And regarding all of these artifacts, I'm only talking about the unpackaged code or the custom code that we wrote on our arc. It does not include managed package, as you know, like we can't have the numbers of on those classes. So you can imagine the complexity of that our arc, right? So now, if you look at the continuous delivery, almost every single day we have deployments going on round the clock. In fact, we have multiple deployments going on any given single day. The reason is like, as we mentioned, like we are spread across 55 plus countries, and we have teams in 4 regions like LATAM, North America, APAC, and EMEA, and our teams are located in 12 plus countries. So there's always some deployment keeps going on. So given this kind of complexity, obviously, we have a lot of problems, right? And in fact, at some point, we used to hit 6,000 governor limit hits per week. That's 6,000. Yes, that's a lot of governor limits. Now we have successfully reduced to 500 plus. Probably this number still may look large, but compared to 6,000, it's obviously like we made a great improvements, right? And we also have this proactive monitoring service with Salesforce, where we get email notifications whenever we hit the thresholds. And this proactive monitoring alert is separate from the governor limit counts, right? So even this limit was much higher, but now we were successfully able to reduce 200 plus alerts per month. And as far as the performance, we have 10 billion records exchanged between Salesforce and other systems every week through our integration platforms. We have multiple integration platforms, MuleSoft, Informatica Cloud, SAP PO, and so on. And all of the systems push and pull information that's close to like 10 plus billion records. Now, regarding the complexity of the customization, the account object alone has 84 validation rules, 40 workflow rules, 6 process builder processes, and few lightning flows, plus thousands of lines of trigger code. And guess what? With all this complexity, we still get single second response time most of the times. Occasionally, it does go to double digit, but most of the time we do get. But as you can see here, right, like it's heavily complex, and there's absolutely no way for us to go and do a manual code check. So what happens today is like, we get periodic reports from CodeScan, and we go through them and we address them. We have certain ways to address that, but again, the point here is that, when you have this kind of complex org, there's absolutely no way that we can do things manually. And this is where tools like CodeScan come to help. Over to you, Nitay. Thanks.
Perfect. That's amazing. Yeah, so this is exactly how static code analysis can help companies like Syngenta with a very complex implementation of Salesforce and a lot of lines of code. So as we discussed at the beginning, when you use a static code analysis tool for your code review process and you put these gates, you define the standards of code development of your organization. And by doing that, you manage to get a good visibility of the code before the review process, and of course, before you push that into the UAT and production. I have a customer that said to me one time that he gets to sleep well at night because of the fact they are using static code analysis with CodeScan. Because he knows that with all the 50 or 100 developers that they have in the organization, everyone needs to put almost the similar code or meeting those gates of standards before they push code for the code review and also to UAT and production. And by using static code analysis, you can enforce those standards exactly, and of course, sleep well at night. So when we speak about the return on investment of these customers, we see that in this graph, this graph shows the scans at each month in the x-axis, each month, and the technical debt on the left axis, on the y-axis. So over time, how our customers manage to reduce their technical debt by running more scans, fixing that, and then moving along into the process. And by doing that, they are just improving the healthiness of their system. When we speak about the other tools out there, right now we are speaking about Salesforce, but there are so many tools that everyone can get. For me, the important thing about choosing your static code analysis is how fit this tool is to your organization. And all of these tools that we see here are really good. We really respect them, and we also work with them. But when we speak about Salesforce, there is one tool that covers 100% of the languages that Salesforce provides, which is Apex, Lightning Web Components, Visualforce, and also the metadata. And this is what we do. The other thing you want to check is how many rule sets the tool provides to your organization. And that defined by all the checks that you can perform to maintain your code. So this is the landscape that we see here. Everyone has a different specialty, mainly in other languages a part of Salesforce. And by that, I will hand it over to Will to walk us a little bit through the platform itself and show us the use case of a customer, how we can define code standards and gain that visibility and also enforce the standards when we push code and commit code into production. All right, Will.
Thanks, Nitay. Yes, so as Nitay mentioned, it is important to choose the right static code analysis for your company, and that either means the right rule set for your company, or just actually the tool that can integrate best into the processes you already have, because we all know less tools are better. But let me just jump, but I'm going to show you a bit of a scenario of how to do this in CodeScan. But as I mentioned, these practices can be performed with any static analysis tool. So we have our steps here, and now to implement them in our process. So to give you an example, I'll duck over to the CodeScan dashboard here. Now, as Nitay mentioned, the first step is defining our standards. And with CodeScan, this is done by setting up two things: your quality profiles and your quality gates, which I'll explain now. So jumping into my GitHub project here, I'll show you where they come into play. Now, firstly, on this dashboard, we can see the amount of issues in each of these categories: our bugs, our vulnerabilities, and our code smells. So bugs are code that can cause your functional issues, your governor limit exceptions like Syngenta is facing. Your vulnerabilities are, of course, your security vulnerabilities. And your code smells are code quality. Now, code quality is important in standardization, because when a developer comes in to a company, starts on development, he's usually working with a lot of legacy code. Now, if there's a defined code standard, especially quality-based, you're able to come into that code and not spend all of your time focused on trying to figure out where everything is. No comments on methods telling you what is going on. So that's very important. Now, the issues that it's finding here are based on a quality profile. So it's a set of rules that we'd like to enforce. So we can see I've got a list of rules here that I want to find, and they're all, these little icons next to them are the severity. Now, I've changed the severity of all of these rules, either from low to critical severities, based on how important they are to me and my organization. Now, the severity of the issues that the tool finds is, we'll change the ratings of these three sections of issues. So we can see here, my vulnerabilities, my rating is C, because there's one major vulnerability in my code. So these ratings are a great high-level indicator of the project health. So I'm going to use them as I continue defining my standards in the quality gate. Now we can see the quality gate here. We can see it's based on the ratings that I just discussed. So if my ratings are worse than A, this quality gate is going to fail. And now that I have both of these gates set, my profiles and my gates, I can start looking towards gaining visibility into my code. So this dashboard that I'm showing you is based on a scan of my code repository's master branch. And scanning this master branch or your production org, it gives you a lot of visibility on issues that may have been on the project for a long time. And using that full scan to plan the refactoring effort is a great idea, but it isn't always possible. Especially when you have an org the size of Syngenta, you've got a lot of legacy code in there. You've got code that may not be used anymore and may not be issues that may not be relevant. It can be very overwhelming. On the refactoring effort size, time is always limited, and every org is different as well. So visibility needs to be narrowed down to where action can be taken immediately. Now, the first step is obviously our IDE. Now, this is where, unfortunately, bugs are born. But by taking this visibility back to the development stage, we can get a lot more speed and start to cut down the time spent in that loop from development to UAT. So by opening, let's go into my beer controller here. Now we can see, let me just zoom in a tiny bit. So we can see these issues start to pop up here, or enabled, needing the error handling, and permissions should be checked before accessing resources. So by having this visibility, as soon as you're typing your code and having some insight into why that's an issue and what the issue involves, developers are able to have a lot more power over what they fix and and pushing cleaner code. So this separates a lot of issues out of the code. But for the developers that aren't fixing anything, comes to our next point, and that's enforcing our standards. Now, so when these issues are pushed, there needs to be a check at the repository stage. Now, once those pull requests are coming in, they need to be gated to these standards, and this is where our quality gate comes in again. Now, I'm going to duck over into my pull request branch here. I've created a pull request against my master branch, which I've scanned. And we can see that this is giving us very few issues. Now this page is giving us the issues that are happening in that pull request as opposed to our master branch. So we're narrowing down the relevant issues and making sure that from this point, we have clean development going into our repository. So this is a step of visibility and a step of enforcing. So making sure you can split your development effort and a clean development effort with a refactoring effort that may take quite a long time, depending on the size of your org, you can really start to get some value out of that selection of issues. So the other side of this quality gate that we've defined happens inside our pull request. So by integrating your checks and your gates with your repositories and your CI tools, we can see here that I've got my pull request and it's passed my quality gates. We can automatically gate these pull requests based on those standards and make sure that the developer knows exactly what they need to do as soon as that happens. They know it's not up to scratch and they can perform that fix themselves. But implementing these 3 steps in any code analysis tool, it can really help your developers move faster and give them confidence in the code they're pushing and give them the power to fix it, so you don't end up in that loop. And once it's gone past, once you know those standards are automated at those stages in the development, it can really give you confidence in your releases as well, and a speed that is not attainable with manual code reviews. So I'm going to hand back to Nitay. Thank you very much.
Yeah, thank you. So I think just as a recap, this is exactly how static code analysis can help any organization that is running any type of development in Salesforce. So by utilizing static code analysis through the code review process, you can define those standards and get the visibility that you need in order to avoid the creation of technical debt, and of course, cleaning the existing technical debt you have in the system. And by doing that, I think we are right on time for questions. Erika, this is back to you.
Yes, we are right on time for questions. Thank you, Nitay, Will, and Harry for such a great presentation. I will go ahead and read the first question here. It says, I have a huge legacy code base. How do I start my refactoring effort?
So in the way that I showed you before on the dashboard, it's really a visibility issue. So once you've defined those standards and you have the visibility on that, you need to sort your issues by how important they are to you. So either if that is a security focused phase, a bug focused phase, or even a severity based phases, planning that by the how critical the issues are to you is very important.
Great, and another question. How would I utilize a development flow like this when some of my development is outsourced / provided by a third party?
That comes into play when you're enforcing the standards. So like I showed you with the pull request in GitHub, if you have a lot of developers that are pushing code to the same thing, to the same repository, sorry, you can really enforce it at those pull requests to make sure that any of those issues don't get past that point based on the standards that you set.
Yeah, just to add on that, we have a lot of customers that they have a development team in-house, and they also use a third-party vendor to run development for other part of the system. So this is exactly where static code analysis can help both of these groups to maintain a good flow of code and avoid the creation of technical debt or just code that doesn't need to be there.
Exactly, yes.
And a really good example of utilizing the capabilities of static code analysis to make sure the system stays healthy.
Exactly, and I think working together, those two teams working together, is a really good point as well, Nitay. Just having this a standard across those two teams, even though there may not be the best amount of communication, which I've seen a few times, but both teams having the same standards really allows those teams to work in harmony and towards the same outcome.
Excellent, thank you. So what we're going to go ahead and do now is I'm going to, we'll end questions here, and I want to give a big thank you to you all, Nitay, Harry, and Will, for such a great presentation and being here today and sharing your insights.
Thank you very much for having us.
Thank you.
Thank you.